Okay guys, let's begin the discussion over the questions. First question says that the equation of the common tangent to the curves y square equals 8x and xy equals minus 1 is what? Now if I talk about xy equals minus 1, on this curve, any general point looks like what? T comma minus 1 by t. T is a parameter. T comma minus 1 by t, right? Now if I consider this as a function of x, I am going to get y equals minus 1 by x. So dy by dx is going to give me 1 by x square. What is the slope of this function at the point t comma minus 1 by t? It is what? X is t. So you get 1 by t square. Therefore, equation of tangent to this curve at a general point will be y minus y1. This is x1 comma y1. So y minus y1 equals the slope into x minus x1. So this gives you y equals x by t square minus 1 by t minus 1 by t, so minus 2 by t. The same tangent, which is a tangent to this curve at a general point, is a tangent to my standard parabola y square equals 8x as well, which is y square equals 4 into 2 into x. So 4ax small a is equal to 2 over here. If this particular line has to be a tangent to the parabola y square equals 4 into a into x, then it has to be of the form y equals mx plus a by m. That is y equals mx plus 2 by m. If you compare both of them, y equals mx, so m comes out to be 1 by t square and 2 by m, 2 plus 2 by m plus 2 by m, so m comes out to be minus t. When you equate both of them, because both of them are values of m for which this particular line is a tangent to my standard parabola y square equals 4 into 2 into x, therefore I equate them, I get 1 equals minus t cube or t is minus 1. The moment I get t is minus 1, what happens to be the equation of common tangent to this curve as well as my standard parabola? It is, what is the answer? Y equals x upon minus 1 square minus 2 upon minus 1, which is plus 2. So y equals x plus 2 is your required answer. Fine. Moving on to the next question. If the tangent at 1 comma 1 on y square equals this curve meets the curve at P, then P is which point? So I need to basically calculate the point of tangency. It is a tangent at this point which is meeting this curve at a point P. So that point basically we need to determine. I know the point of tangency is 1 comma 1. Now if I try to get the curve, basically I should get the curve, it is x 2 minus x whole square. So let's differentiate. I get 2y dy by dx equals x. Now you differentiate this, you get twice of 2 minus x into minus 1 plus 2 minus x whole square into d by dx of x, which is 1. So first number into differentiation of the second number plus second number into differentiation of the first. So from here you get x, or I can say minus 2x common. Inside you have 2 minus x plus 2 minus x whole square. This is what you get. Now over here you have 2 minus x common. Inside you have minus 2x plus 2 minus x. Right? So this gives you 2 minus x. And then what is it that you have over here? Now here if you try to get what we are getting is, this is okay, minus 2x minus x, which is minus 3x plus 2. And so dy by dx turns out to be all of this upon 2y. Right? 2 minus x minus 3x plus 2 whole upon 2y. What is dy by dx at the point 1 comma 1? That is what we need to evaluate. What is dy by dx at the point 1 comma 1? It is 2 minus 1, that is 1, minus 3 plus 2, that is minus 1, whole upon 2 into 1, that is 2. So, minus 1 by 2. Therefore, equation of tangent at 1 comma 1 will be what? Y minus y1 equals m into x minus x1. So, this gives you what? Y is minus x by 2 plus 1 by 2 plus 1, which is minus x plus 3 whole upon 2. Now, y is equal to minus x plus 3 whole upon 2, and I know it is going to satisfy the equation of this curve because the tangent is on this particular curve. It is meeting the curve at point P. That means y equals minus x plus 3 by 2 is going to satisfy the equation of my curve. So, I will be getting y square, which means minus x plus 3 by 2 whole square equals x into 2 minus x whole square. When you resolve this, you get x minus 1 whole square, 4x minus 9 equals 0. Already I know that x equals 1 and y equals 1 is a point of tangency. The other point is x equals 9 by 4. And if x is 9 by 4, what is y? Y we are going to get from here. If x is 9 by 4, y square is 9 by 4, 2 minus 9 by 4 whole square, which is 9 by 4. This is minus 1 by 4 whole square, which is 9 by 4 into 1 by 16, which is 9 by 64, and therefore y comes out to be 3 by 8. So, therefore, x is 9 by 4 and y is 3 by 8. This is that particular point where the tangent to this curve at this point meets this curve. It is 9 by 4 comma 3 by 8. Moving to the next question, we have if fx is this curve x into e to the power x 1 minus x, then fx is increasing or decreasing over which interval? Let's talk about this now. Again, to talk about the increasing and decreasing behavior of a function, we need to consider its derivative, right? So, if I talk about fx, it is x into e to the power x into 1 minus x. F dash x is what? First number into differentiation of second. So, this multiplied by differentiation of x into 1 minus x, which is what? Which is x into minus 1 plus 1 minus x. This thing, and then you have plus e to the power x into 1 minus x into d by dx of x, which is 1 only. So, you get x, inside you have e to the power x into 1 minus x. This is minus x plus 1 minus x, so 1 minus 2x. So, you basically get x into 1 minus 2x, and this is e to the power x into 1 minus x. You can take out this common. You are left with x minus 2x square plus 1. Again, you can take out minus sign common, and you are left with 2x square minus x minus 1. Right? This gives you what? Let's see. Let's evaluate the expression further. You get minus of e to the power x 1 minus x. This is 2x square minus 2x plus x minus 1. So, you get minus of e to the power x 1 minus x. Here you have 2x x minus 1 plus 1 x minus 1. So, you are getting minus of e to the power x 1 minus x, x minus 1, 2x plus 1. Now, talking about increasing or decreasing behavior, you know that this is always positive for every x. If this is always positive for every x, I know minus of this is always negative for every x. If I want to talk about increasing, f dash x needs to be positive. This portion is always negative. So, when is this going to be positive? Only when this is negative. Because this portion is always negative, minus of a positive thing is a negative thing. The moment this expression comes out to be negative, I will get f dash x to be positive. So, what are the places where this is negative? At those places f dash x is positive and hence f is increasing. So, what are the places at which this is negative? This is what? 1 and minus 1 by 2. You will be able to see here it is positive, here it is negative, here it is positive. So, this expression is negative in this interval minus 1 by 2 to 1 it is negative, and hence in minus 1 by 2 to 1 this entire expression is positive, that is f dash x is positive in the interval minus 1 by 2 to 1 and f is increasing therefore in minus 1 by 2 to 1. Clear? Moving to the next question, we have fx is given to us as x square plus 2bx plus 2c square and gx is minus x square minus 2ax plus b square. They are two functions given to us such that minimum of fx is greater than maximum of gx, and the relation between b and c is what? If I talk about fx, it's pretty simple to understand. This is x square plus 2bx plus b square minus b square plus 2c square. I am just completing the square. What I get is x plus b whole square plus 2c square minus b square. F is going to be minimum when this is going to be 0 because this is always non-negative, right? So, minimum of fx will be when this expression is 0. In that case, you get 2c square minus b square. Talking about gx, it is minus x square. So, minus common x square plus 2ax plus a square minus a square minus b square, because minus we have taken out common. So, this gives you minus of x plus a whole square minus a square plus b square. Or rather you can say a square plus b square minus x plus a whole square. Okay. So, here if I talk about max of gx, maximum will be when this is 0, nothing is being removed from a square plus b square. When 0 is being removed from a square plus b square, because this is always non-negative, it is either 0 or greater than 0. If it is greater than 0, something greater than 0 is being removed from a square plus b square, this term will be less. So, minimum what can be removed from a square plus b square is 0, because this is either 0 or greater than 0. So, the minimum when this will be minimum, this complete thing will be maximum. This is minimum when this is equal to 0. So, maximum will be a square plus b square minus 0. So, maximum of gx is a square plus b square. It is given that minimum of fx is greater than maximum of gx. Minimum of fx is greater than maximum of gx. So, you get 2c square minus b square is greater than a square plus b square. So, over here, if I talk about this particular expression, here it is not a square, it is actually c square. So, this shouldn't have been a square. This is everywhere, wherever there is a, there is c, okay. So, this is c. So, here this is what we get, just in place of a you replace c, because everything is in terms of b and c. So, you get 2c square minus c square is greater than 2b square, which means c square is greater than 2b square, or you can say mod c is greater than 2 mod b. Okay. So, everywhere in place of a you can just substitute c, you are going to get that mod c is greater than 2 mod b is basically your answer, or I can basically say here root 2, of course. This is root 2 because we are taking the square root first and then putting the mod. So, square root of c square is mod c, then square root of 2 and then square root of b square is mod b. So, mod c is greater than root 2 times mod b. Okay. Next question, let us see what is it. This function decreases in which interval? Let us see. Tan inverse x minus e to the power x. Let us talk about the behavior of this function decreasing. F dash x will be 1 upon 1 plus x square minus 1 minus e to the power x. So here this will be 1 minus 1 minus x square minus e to the power x 1 plus x square whole upon 1 plus x square. Now this becomes minus x square upon 1 plus x square minus e to the power x, right? Minus you can take out common, you will be left with this. Now understand, this is always greater than equal to 0, this is always greater than equal to 0, this is always greater than equal to 0, so the sum of non-negative is also non-negative. If this term is always positive, if this term, in fact this is strictly positive, so if this term is always positive, this is also strictly positive. If this term is always positive, the negative of it is always negative. So pick up any x, for that f dash x is always coming out to be negative, that means fx is throughout decreasing in the entire real line. Okay? Moving to the next, we have, let f be a differentiable function with range being 0 to infinity. If range is 0 to infinity means fx is strictly positive function throughout. Then gx is defined like this. I have to talk about g being increasing or decreasing. So I will be interested in g dash x therefore, which will be 2 fx f dash x minus 3 fx square into f dash x plus 4 fx cube into f dash x. If from here you take out 4fx f dash x common, 4fx f dash x, you will be left with 2 by 4 minus 3 by 4 fx plus fx whole square. So this gives you 4fx f dash x, inside you have fx whole square minus 3 by 4 fx, let's complete the square, plus 3 by 8 fx, or I can say plus 3 by 8 whole square minus 3 by 8 whole square plus 1 by 2, because 2 by 4 is 1 by 2. This gives you 4fx f dash x, and this is fx minus 3 by 8 whole square. Then this is 1 by 2 minus 9 by 64, which is 23 by 64. So you get plus 23 by 64. Now see, try and analyze something. This is a non-negative function. This is always greater than equal to 0. This is always positive. So this complete bracketed thing is always positive. I should just write positive. Fine. 4fx, fx is given to be positive because the range is given to be 0 to infinity, so this is positive. That means g dash x will be positive if f dash x is positive, because rest everything is already positive. If f dash x becomes positive, the entire expression will be positive. If f dash x becomes negative, negative into positive is negative, so the entire expression will be negative. So I can say that g dash x is positive if f dash x is positive, and g dash x is negative if f dash x is negative. In fact, g dash x is 0 if f dash x is 0. So this means whenever f is increasing, then g will increase. Whenever f is decreasing, then g will decrease. Whatever are the critical points of f, same are the critical points of g. So my answer is g is increasing whenever f is increasing, g is decreasing whenever f is decreasing, and critical points of g are same as that of critical points of f. Moving to the next question, what we have, let's see, let f be a differentiable function for all x. If f of 1 is minus 2 and f dash x is greater than equal to 2 for all x in the interval 1 to 6, then talk about these inequalities being true or false. So over here, the moment I am giving you all the hypotheses, Directly Lagrange mean value theorem I will be interested in. I will say there exists C in this interval such that f dash C is f of B minus f of A upon B minus A. This gives you 5 times f dash C equals f of 6. F of 1 is given as minus 2, so this is plus 2. So you are getting f of 6 is actually 5 times f dash C plus 2. C is a member coming from this interval. For every member coming from this interval, f dash x is greater than or equal to 2. So f dash C will be greater than or equal to 2. So this will be greater than or equal to 5 into 2, and here it will be minus 2. This is fx plus 2, then this will be, here it will be minus 2. Right, so this will be f dash C is greater than or equal to 2. So 5 f dash C minus 2 is greater than or equal to 5 into 2 minus 2, which is 8. So I am getting that fx is greater than or equal to 8. Obviously, if something is greater than or equal to 8, it is obviously greater than 5. So C automatically comes out to be true also. Next question we have, fx is 2 to the power x minus 1 into 2 to the power x minus 2, and gx is also given to you. Match the column in the first to the second. So again, talking about f dash x, first of all, if I dissolve fx into a single expression, I get 2 to the power x into 2 to the power x, which is 2 to the power 2x, minus 2 times 2 to the power x minus 1 times 2 to the power x, which is minus 3 times 2 to the power x plus 2. So f dash x therefore becomes 2 to the power 2x into log 2 into 2 minus 3 into 2 to the power x into log 2 plus 0. So from here, now I can write this as 2 to the power x into 2 to the power x plus 1 log 2 minus 3 times 2 to the power x log 2. So 2 to the power x log 2 comes out. You are left with 2 to the power x plus 1 minus 3. You know that 2 to the power x is always positive, greater than 0. Yes, 2 to the power x is greater than 0, log 2 is always greater than 0. The moment this comes out to be greater than 0, I am going to get f dash x to be positive. So this is greater than 0 when 2 to the power x plus 1 is greater than 3, or I can say x plus 1 log 2 is greater than log 3, or x plus 1 is greater than log 3 by log 2 or log 3 to the base 2, or I can say further, I want condition on x, that is when x is greater than log 3 to the base 2 minus 1, 1 can be written as log 2 to the base 2. So this becomes what? Log of 3 by 2. Okay, that means f increases in which interval? Log 3 by 2 to infinity, and f decreases in which interval? Minus infinity to log 3 by 2 for sure. Log 3 by 2 to infinity contains this interval, therefore f increases in this interval, and minus infinity to log 3 by 2 actually contains this interval, therefore f decreases in q. If I talk about the next function, that is g, g is what? It is 2 sin x plus cos 2x. So when I differentiate it, what I get is 2 cos x minus 2 sin 2x. This becomes 2 cos x minus 2 into 2 sin x cos x. Again 2 cos x can be brought out common. So 2 cos x, when you bring out common, you are left with 1 minus 2 sin x. Right? Clearly this function's period is 2 pi. So only in 0 to 2 pi closed interval, let's observe the behavior. When is it increasing, decreasing? Now this is pretty evident because I have functions whose graph I am very well aware about. g dash x is positive when x belongs to 0 to pi by 6 union pi by 2 to 5 pi by 6 union 3 pi by 2 to 2 pi, and therefore it decreases on pi by 6 to pi by 2 union 5 pi by 6 to 3 pi by 2. So now I know it increases in R and decreases in S. So C gets mapped to S and D gets mapped to R. Fine. Moving to the next question we have, there are equation of tangents drawn to this curve from this point are this or not. Okay, so we need to verify whether the equation of tangent drawn from 1, 2 to the given curve are these given ones or they are not. Okay, so I am saying that let the tangent drawn from 1, 2 to this given curve meet the curve at h comma k. Okay, suppose the point of tangency is h comma k, basically is what I am trying to say. In that case, what is the equation of tangent which is drawn at the point h comma k to this curve? For that I need the derivative. I am going to say 2y dy by dx minus 6x square plus 4 dy by dx plus 0 equals 0. So dy by dx you have common, you are left with 2y plus 4 equals 6x square. So your dy by dx is what? 3x square upon 2 comes out common, you are left with y plus 2. Right? This is what you have. So you have 2y dy by dx minus 6x square, this is minus, not plus, this is minus. So here also this is minus and here also this is minus. It's like 2 comes out common, so 2 and here you get 3, so you get 3x square upon y minus 2. So therefore dy by dx at the point h comma k, this is nothing but the slope of the tangent to the given curve at the point h comma k, becomes 3h square upon k minus 2. Therefore equation of tangent becomes what when you know the point and the slope? It is y minus y1 equals m into x minus x1. This is one equation in h and k. Also, because h comma k lies on the curve, you know this, h comma k lies on the given curve, therefore it is going to satisfy the equation of the curve also. You will get k square minus 2h cube, k square minus 2h cube minus 4k plus 8 will be 0. When you solve 1 and 2, you get h comes out to be minus 1 and 2. But with h equals minus 1, when you put over here in the second equation, you don't get real values of k. So you basically don't take h equals minus 1, you take h equals 2. And for that, what are the values of k that you get? Let's see. K square minus, so h is 2, 2 cube is 8, so this is minus 16, minus 4k plus 8 equals 0. This gives you k square minus 4k minus 8 is 0, which implies k is, just apply the quadratic formula, it is 4 plus minus root over 48 by 2. 48 becomes 4 root 3. So you get 2 plus minus 2 root 3. Right? So corresponding to h equals k, k is coming out to be 2 plus minus 2 root 3, and therefore what is the equation of my basically tangent drawn from 1 comma 2? It is y minus k. So y minus k is what? 2 plus 2 root 3 equals m. Now if I talk about m, it is 3h squared, that means 3 into h is 2 upon k minus 2. So 2 plus minus 2 root 3 minus 2 is going to just leave you with 2 root 3, and that gives you what? This gives you 6 by root 3. This is 2 into root 3, that is it. So you get m, that is 2 root 3 x minus x1. And another tangent is y minus 2 root 3. This is the value of k, another one. Corresponding to it, again you get the slope 2 root 3 into x minus 2. So yes, these two are definitely the equations of the two tangent, and statement 2 says that the two tangents can be drawn from 1 comma 2 to this curve. So yes, this is also true. Both the statements are true. Statement 1 is true and statement 2 is true. I can say statement 2 is true. It is giving you that two tangents can be drawn, and here it is giving you the equation of the two tangents. So I can say 2 is implying 1. So statement 1 is true, statement 2 is true, statement 2 is correct explanation for statement 1. Moving to the next, we have, if the greatest value of y equals x upon log x in this particular interval is u, then what is e cube by u? Okay, so if I talk about this function, let me take y equals fx. It is x upon log x. Just apply the division rule. What you get is log x into d by dx of x minus x into d by dx of log x, which is 1 by x. Right? Log x into d by dx of x minus x into d by dx of log x, which is this whole upon log x whole square. So this gives you log x minus 1 upon log x whole square. Now I want to talk about this increasing function. So f dash x I want to be positive. You all know this is always positive. Just if the numerator is also positive, this entire fraction will be positive. So this will be positive when log x is greater than 1 or x is greater than e. Yes, that means in this interval, x is greater than e, in this interval, f is increasing. If f is increasing in this interval, maximum of f will be what? It will be attained at the very end point of the interval. Max of f will be attained at e cube. So f is x upon log x. So e cube upon log of e cube. And max is given by the letter u. It is given in the question. So you get e cube upon 3. Log e to the base e is 1 only. So u is coming out to be e cube by 3. Therefore, e cube by u is the integer 3. What is e cube by u? It is the integer 3, because u is actually e cube by 3, which is the maximum value of this function on the interval e comma e cube. Okay, that completes our discussion over the questions. Revise all of them very nicely, practice them hard. That's it from my side. Thank you.